decade ago, forging a performance with this level of photorealism required a multi-million-dollar Hollywood studio and massive teams of visual effects artists. Today, anyone with a standard desktop computer and open-source software can execute the exact same illusion. For over a century, society has relied on photography and video as our ultimate arbiters of objective truth. If a camera captured an event, we believed it happened. Traditional computer-generated imagery worked by forcing artists to draw digital puppets from scratch. Deepfake technology abandons that approach. Instead of drawing an image, an artificial intelligence uses complex mathematics to study and memorize the precise behavioral patterns of an existing human face. Because these seamless outputs bypass our visual instincts, identifying the forgery requires us to look past the surface. We have to go inside the algorithmic black box to see how the AI actually processes these images. The process begins with raw data collection. To build a convincing forgery, the artificial intelligence requires a massive visual dataset, thousands of individual images of the target face it wants to copy, and thousands more of the source body it plans to paste that face onto. This animated diagram shows how the algorithm begins processing those raw images. It scans every single frame and identifies strict geometric landmarks, locking on to the precise distance between the corners of the eyes, the bridge of the nose, and the edges of the mouth. Once tracked, the data is fed into a neural network component called the encoder. The encoder's specific job is extreme data compression. It systematically strips away the visual pixels, discarding the colors, light, and textures that make up a recognizable image. The encoder translates physical features into numbers, collapsing into latent space, the mathematical essence of a face. Visual identity is replaced by coordinate values for lighting, angle, and expression. Isolating a data node shows zero resemblance to human anatomy. The machine only processes equations. The machine executes this compression at an immense scale, applying mathematical reduction across thousands of individual video frames in a fraction of a second. Before a machine can convincingly rebuild a face as a forgery, it must completely destroy the original image into abstract mathematics. With the visual data successfully compressed into raw math, the system shifts to the second half of its architecture, attempting to rebuild a human face. This task is handled by a separate component called the decoder. Its purpose is to exactly reverse the encoder's process, taking latent space coordinates and inflating them back into visual pixels. The system trains through a rigorous loop. The decoder draws a face, compares it to the original photograph, identifies the tiny mistakes, and updates parameters to correct them. That error correction process loops millions of times. The network runs relentlessly until the reconstructed face perfectly matches the original data. Reconstructing an existing photo is simply the training exercise. The deepfake itself is born during the swap, where the internal architecture is intentionally crossed. First, the target body's movements are compressed into latent space math via the encoder. Then, that math is intercepted by the source's decoder. The system must draw person A's face using the exact mathematical coordinates of person B's movements. This illusion succeeds through a mathematical translation of human behavior, moving beyond simple pixel manipulation to map one person's identity onto another's. Even with the swap executed, the AI must clear a final technical hurdle. It performs a final blending pass to remove any digital scenes where the synthetic face meets the real body. This step requires precise, localized adjustments. The algorithm matches the exact skin tone, recalculates the ambient shadows of the room, and applies an artificial digital grain so the generated pixels match the camera noise of the original footage. When machines can automate perfection, it alters the burden of proof in the modern world. Our human eyes and brains evolved to detect physical anomalies in our immediate environment. We are biologically incapable of spotting mathematically synthesized lies on a screen. Relying on the traditional assumption that seeing is believing has become a liability. Visual evidence can now be manufactured with the same precision as the truth. To navigate a world of synthetic reality, society has to adapt. We must replace our reliance on visual intuition with strict source verification, digital forensics, and deep critical media literacy.